What's up with the freezer? We wanted to find out. So we used our new What's Up Pro energy meter, an older computer, and a LabQuest to measure the temperature measured by a stainless steel temperature probe inside basement freezer over a 48-hour period. So if we look at the graph that Lugger Pro produced during that time, we see we get a nice regular pattern of temperature versus time and a graph of the power in watts versus time. So if I want to see what the temperature was at any given moment, I can just select my temperature graph and then turn on the examine tool in the toolbar, and now as I move back and forth across my graph, I can see what the temperature was at any given time. If I want to perform the same examination on the power graph, I just select the power graph, turn on the examine tool for that graph, and now as I move back and forth, I can see what the temperature and the power use was at any given moment. So as I go back and forth, I see a really nice regular pattern there in what's going on with the temperature, and then it seems to be going from a pretty regular minimum temperature of about minus 28 C up to a high here of around minus 16 C. And during that warming time, it looks like not much was happening down in the power graph, but then when it starts to drop in temperature, that seems to correspond to when the freezer was using more power. But then we notice an interesting pattern here where every other one of the spikes in the temperature data seems to be accompanied by a matching large spike in the power data. So when I first saw this, I scratched my head for quite a while and couldn't quite figure out what was going on. And I had several different ideas, and none of them quite seemed right until I asked our electrical engineer about it, and he said, "Oh, well, that's probably when the heater was kicking on." I said, "The heater? What do you mean? Why would there be a heater in my freezer?" And he said, "Oh, well, that's how frost-free works." So I didn't know that. There's a heating element in the freezer that warms the walls to melt any of the ice, which then can run out of the freezer as liquid into a pan that's outside the cold part of the freezer, where it can just evaporate. So I wondered what effect this would have on the energy use, so I wanted to look a little closer. So if I just draw a box around an area of the graph, which I just click and drag to highlight that region, now I can zoom in by just clicking the magnifying glass with the plus on it, and now I'm looking at just one of those cycles of the temperature versus time. So this is that large spike in the temperature graph, which you can see again corresponds to what looked before at the other scale to be a spike in the power data, but now it actually looks like a plateau. So that corresponds to when the heater was running, which heats up the inside, and before the compressor kicks on and starts to drop the temperature again. So if I want to know how long that heating element was running, I can actually just click down here on the graph around that region, and it highlights that part of the graph for me. And then down at the bottom of the graph, I see I have a readout for delta T and delta W, telling me a change in time and the change in the watts during that region. Well, I'm really just interested in the change in the x-axis, which is time here. So it looks like about 11 minutes. So 10 or 11 minutes probably. Every time that heater kicks on, it's running at about 400 watts compared to when the compressor is running at around 110 watts. So almost 4 times the energy use while the heater is running. So I'm going to zoom back out. I'm just going to click on the auto scale so I can see that whole trend again. As you examine data like these with students, you might ask questions like, what else could we do to lower our energy bill? Could we make the temperature in the freezer warmer, cooler? What can we do to make the compressor run more often or less often? And how does the freezer compare to other household appliances?